Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of factorization, where I will discuss about how to factorize special form of polynomials. And also I will illustrate the concepts by solving problems from the exercise 7B, 7C and 7D from the textbook of author RS Aggarwal. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are not subscribed to my channel or if you are new to my channel and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my quick notes on the left hand side, and on the right hand side I will solve the problems. I hope you can the link of the PDF of the quick notes will be given in the description below. You can check that out. You can check it out from there. I hope you can see the fonts. The quick notes fonts is big enough and you can read it properly. Okay, so let's start discussing about today's video, that is how do we factorize some special form of polynomials. Let me quickly check if everything is visible or not. Okay. So sorry, I was scribbling on my canvas. Anyway, so okay. So we will study about how to. There are some special polynomials that can be factorized easily. Some are you are already familiar from the previous chapter. Those are algebraic identities. Like the first one is difference of squares. Now, if you see any polynomial of the form a square minus b square, then you know from the algebraic identity this we can write it as a minus b multiplied by a plus b. So we factorized a square minus b square as a minus b, product of a minus b and a plus b. Now also remember that you may not be the polynomial a square minus b square can also be, it may not have any square. For example, as you can see on the notes, let's say you have twice x minus, let's say 3y, and if you are asked to factorize this polynomial, you might be thinking, how can we factorize? It is not in the form of squares. It is not in the form of a square minus b square. Now the answer is no. You can factorize this, because you can express any number as a square, or rather any expression or term as a square. So 2x, I can always write it as square root of 2x square of 2x, and 3y, I can always write it as square root of 3y square of root of 3y. Now I see I get the form a square minus b square. Then I can apply the a square minus b square identity, and I get root of 2x minus root of 3y multiplied by root of 2x plus root of 3y. So this is a little bit of information that if you have any expression in the form a minus b, where a can be any term, and b can be any term, then you can always factorize a minus b as for example, if you have any polynomial of the form a minus b, that is difference of two numbers, and if you are asked to factorize it, then you can always convert, or you can always express a as square of root a. Root a means square root. Square of root a minus square of root b, because we know that for any non-zero number we know that square root of x, if you take its square, it is always x. So now we can say that this is equal to root of a minus root of b multiplied by root of a plus root of b. So this is just to illustrate that you can apply the identity a square minus b square equals to a minus b into a plus b not only for polynomials of the form a square minus b square, but also if you are given any difference of any two terms, you can apply that identity also. Okay, now there are some examples in the quick notes. I will not discuss all of them. If you see the notes, you will understand them. It's pretty straightforward. So this was difference of squares. Now, even though a minus b may not look like difference of squares, but you can always express a minus b as a difference of squares, like square of root a minus square of root b. Okay, the next one is sum of square of sum and difference, like square of sum and difference. So it will be of the form a plus b whole square. Now you will not be given, definitely you will not be given the polynomial, the polynomial to be factorized. You will not be given in the form a plus b whole square, but you will be given a square plus b square plus twice ab. If you see any polynomial of the form a square plus b square plus twice ab, then you can rewrite it as a plus b whole square. So a plus b whole square is the factorization of the polynomial a square plus b square plus twice ab. Similarly, a minus b whole square is the factorization of the polynomial a square plus b square minus twice ab. So these are identities, these are identities you have studied from the previous chapter, that is algebraic expressions and identities, which I have already covered. If you want to study those that chapter, you can check this playlist. Okay, the next is sum or difference of cubes. Sum or difference of cubes. So if you have any polynomial of the form a cube minus b cube, where a and b can be any terms, a and b can be any terms, this we know can be factorized as, which is basically an identity, a minus b multiplied by a square plus ab plus b square. Also a cube plus b cube, that is the sum of cube of two numbers, or rather two terms, can be expressed as a plus b multiplied by a square minus ab plus b square. So you can always factorize. So you can always factorize difference of cubes of two numbers, or the sum of cube of two numbers, not numbers but terms. So this was sum or difference of cubes. The next is cube of sum and difference. For example, cube of sum and difference means if you are given, a plus b cube. This is what I mean by cube of sum. This also we know there is an identity. This is equal to a cube plus b cube plus 3ab multiplied by a plus b. So this is an identity, and we say that a plus b whole cube is the factorization of the polynomial a cube plus b cube plus 3ab into a plus b. Similarly, a minus b whole cube is the factorization of the polynomial a cube minus b cube minus 3ab multiplied by a minus b. You have learned this as an algebraic identity in your previous chapter, but this can also be applied to factorize polynomials which are on the right hand side of the equality sign. So this was cube of sum or difference. Now comes quadratic trinomial. Any polynomial of the form quadratic trinomial, which is very, very important. Quadratic. Now, what is trinomial? Trinomial means a polynomial having three terms. So that is a trinomial. And what is quadratic? Quadratic means the degree of the polynomial is 2. For example, this this is the general form of a quadratic trinomial x square plus px plus q. P and q are constants and the variable is x. So this is a quadratic trinomial with one variable, that is x. So how will you factorize this? So if you are given any polynomial of this form, that is it has only one variable, that is x, instead of x it could be any other variable, like it could be y or z or t, any other variable name, and there will be no coefficient of x square, and you will have a coefficient p of the term of the variable x, or rather the term having the variable x, and there will be a constant term q. So the idea is that you have to find based on the constants p and q, you have to find two numbers a and b. You have to find two numbers a and b, that is, find a and b such that a plus b will be equal to p, and a multiplied by b will be equal to q. If you have found, once a and b are found, we can say that the polynomial will be x square plus p, we know, is equal to a plus b. So we will write, instead of p, we will write a plus b x, and q we know as ab. Now this can be factorized. This polynomial, it can be factorized if you x square plus ax plus bx plus ab. This is equal to, if I create two groups, this is group 1 and this is group 2, then I can rewrite the groups. I can take the factor x from the first group, that is, it will be x into x plus a, and I will take factor out b from the second group, it will be x plus a. Now I can see that the groups are having a common factor x plus a, so this will be equal to x plus a multiplied by x plus b. Now, okay, now so we have factorized x square plus px plus q as x plus a multiplied by x plus b, where the constants a and b have been computed or found based on the constants p and q in the original polynomial. So this is one form of a quadratic trinomial, that is x square plus px plus q. Now there is another form of trinomial that can also be factorized, that is px square. So we will have a coefficient of x square, that is px square plus qx plus r. If you have this kind of polynomial, then also you have to find a and b, that is the numbers or constants a and b, such that a plus b will be equal to q, and a multiplied by b will be equal to pr. Now if you substitute the value, if you now rewrite the given polynomial in terms of a and b, so px square, so this is px square. Now okay, so let it be px square, and we know q is a plus b, so we have a plus b multiplied by x, and we have r we can rewrite as from ab equals to pr, we can say r equals to ab by p. So we will write r as ab by p. Okay, now this becomes, so we have px square plus a plus b into x plus ab by p. How do we factorize this? If you simplify it further, we have px square plus ax plus bx plus ab by p. So this is equal to, from you can px. Okay, you can form groups from the first two terms, first group, and you can form the second group. This is I'm applying the concept of factorizing a polynomial using grouping, which I have already discussed in the previous video. So we have formed group 1 and group 2, where the group 1 contains is px square plus ax, and the group 2 is bx plus ab by p. Now from the group 1, I will take x as common. I will factor out x, and I have x multiplied by px plus a. And from the group 2, I will factor out b by p. I will factor out b by p, and this becomes b by p. So this becomes p into x plus b. No, sorry, into a. So we can see that both the groups are now having the common factor px plus a. So this becomes equal to x plus b by p. Now it is definitely, you will not memorize this. You will not memorize this. Based on the constants p, q, and r in the given polynomial, you have to find a and b. The main task is to find a and b such that a plus b will be equal to q and a into b will be equal to pr. That is the main task. You need not remember this formula. Once you have found a and b, you can replace. You will have. You can replace the given polynomial in this form. Then you can easily factorize. It will be easy once you have substituted the constants in terms of a and b. So this was the second form of trinomial, quadratic trinomial, which can be factorized. What else? Okay. Now this is all about the concepts. In the notes, I have given some examples of factorizing some polynomials based on all the concepts that we have discussed in this video so far. Now I will solve the problems of exercise 7b, c, d to illustrate how we apply the concepts. That is how we apply the factorization of special form of polynomials. Okay. There are quite a few problems, so it will take a time. Let me see if I can do it fast. Okay. So I will solve the selected problems which are marked with blue right sign. Okay. So let's solve some problems so that we have a hands-on practice in applying the concepts in solving the problem. So this is exercise 7b. Okay. The first one is 6. It is 9a square b square minus 25. Now 25. Now you can clearly see that it is roughly in the form a minus b. It is a difference of two terms. Now if you are asked to factorize a difference of two terms, first you will see whether the two terms are in the form of squares. If they are already in the form of squares, then you are done. You know that you will apply a square minus b square. But if the two terms are not in the form of squares, you will have to somehow express the terms as squares. So this is easy. We know that 9a square b square is square of 3ab, and 25 is definitely 5 square, and I clearly get a square minus b square, and I know this will be a minus b multiplied by a plus b. So this was easy. Okay. Let's do 8. It is 63 a square minus 112 b square. Now one more thing, if you have first of all, please remember that try to remember all the concepts that we have learned in factorization. In the previous video we discussed that if all the terms of the polynomial have a common factor, we would like to factor out that common factor as a monomial, and then we will see once we have factor out the common polynomial, we will get a product of two algebraic expressions. That is, one will be a monomial and another will be a polynomial, and that polynomial we have to see if we can further factorize that polynomial. So in this expression at 63a square minus 112b square, we know that a square is in the form of square, b square is in the form of square, but 63 is not square of any number, as well as 112 is not square of any number. Now I would like to see whether I can factor out any common number from 63 and 112. So 63 is 9 into 7, and 112 is it will be divisible by 3. So this is 3 multiplied by 39. 3 multiplied by 39, and so this is 3 multiplied by 3 multiplied by 13. So I can see this is 9 multiplied by 13. So I can see there is a common factor 9 between 63 and 112. So I will immediately factor out 9. Factor out 9 from the polynomial, and this will become 7a square. 7a square. Now seven a square minus 13b square. 13b square. Hundred and 12 is 3 into oh, I did it wrong, sorry. 113 is not 3 into 39, but 113 is 3 into oh, it is not divisible by 3. I'm sorry. Is it divisible by it is divisible by 7. So 112 is 7 multiplied by 16. Okay. So I can see there is a common factor of 7 from the number 63, 100, 112. So I will factor out 7, and I get 9a square minus 16b square. So now I can see that 9a square is in the form of a square, that is, it is the square of 3a square, and 16b square is square of 4b. So now I can see I can factor out this polynomial as using the formula a square minus b square, that is 3a minus 4b multiplied by 3a plus 4b. So when you have this kind of terms, sum of two numbers, sum of two terms, difference of two terms, where the terms are having, the variable part is having some squares, but the constant is not a square of any numbers, is not a perfect square, then you would like to see if you can factor out some number from the two coefficients. That will probably leave with the two terms whose coefficient will also be a perfect square. Just like in this example, when we factor out 7, we are left with 9 and 16, which are both perfect squares. Okay. Let's do 10. So 10 is 12 x square minus 27. So we can see that 27 it is of the form a minus b, but it is not of the form. The first term is 12 x square. We are having the x square, but the second term is 27, which is not a perfect square. So we will like to see how we can take out some common factor so that the two terms with will be left with coefficients which are perfect squares. So 12 is 4 multiplied by 3 and 27 is 9 multiplied by 3. Now if you take 3 common, the 12 will be left with 4 and 27 will be left with 9, and they are perfect squares. So I will take 3 common and I have 4x square minus 9. Now this is equal to 3 into square of 2x minus 3 square. So now I will apply the formula a square minus b square, and I get 2x minus 3 multiplied by 2x plus 3. So while I am solving the problems, you can pause the video and take screenshot of the solution if you think it will help you. Okay, let's do problem number 11. It is x cube minus 64x. So in this polynomial, we see that it is the difference of two terms, but neither of the two terms are in the form of squares. X cube is not a square, 64x is also not a square. So the first method or strategy you would like to have is that if you can take out some common factor from all the terms, after taking out the common factor, maybe you will have. So if I can see that x is a common factor of both the terms. So if I take out x as common factor, I have x multiplied by x square minus 64. Now I can see that x square minus 64 is in the form of a square minus b square, because 64 is 8 square. So now I will factorize x square minus 8 square. It will be x minus 8 multiplied by x plus 8. Okay, let's do problem number 12. I'm trying to solve as many problems so that you have a better idea how to apply the concepts or how to approach. This is 16 x to the power 5 minus 144 x cube. So we can see neither of the two terms, it is the difference of two terms, and neither of the terms are in the form of squares because we have x to the power 5 and x to the x cube. Now I can clearly see that I can take out x cube as a common factor from the variable part, and also let's see what common factor we can take out from the coefficients. Now 16 okay, so now 144. Now when you have to be very careful in taking out the common factor from the coefficients, because once you have taken out the common factor from the coefficients, the two terms, the coefficients of the two terms, remaining terms must be a perfect square. So 144 can be is equal to 16 into 16 into 9. 144 is equal to 16 into 9, and we have 16. 16 is equal to 16 into 1. Now I can clearly see that if I take 16, factor out 16 from the coefficients, both the coefficients of the terms, I will be left with 9 and 1, which are perfect squares. So I would like to factor out 16 from the coefficients and x cube from the variable part. So I have 16 x cube. Factor out after factoring out 16 x cube from both the terms, I get this will be x square and this will be 9. So now I can easily factor out x square minus 9, because this is x square minus 3 square. So this is equal to 16x cube and x minus 3 multiplied by x plus 3. Okay. Problem number 13 is 3x to the power 5 minus 48 x to the x cube. So I can see that I can factor out x cube from both the terms, and also I have to see what can be factored out from the coefficients, so that after factoring out the remaining coefficients in the two terms will be perfect squares. So I can clearly see that 48 is equal to 3 multiplied by 16, and 3 is equal to 3 multiplied by 1. Now if I take out 3 as the common factor, I am left with 16 and 1, which are perfect squares. So I would like to factor out from the terms 3 and x cube. So I have x square minus 16. So we have 3x cube, and x square minus 16 is 4 square. So this is equal to 3x cube. Now I will factorize x square minus 4 square as applying the a square minus b square, and I get x minus 4 multiplied by x plus 4. Okay, let's do 14, let's do 16. Uh, 16 is 1 minus b minus c square. Now we see that the polynomial is in the form of a difference of two expressions. That is, first expression is 1 and the second expression is b minus c square. So already the second expression is in the form of square, but the first expression is 1, and we know that 1 can always be written as 1 square. So we have 1 square minus b minus c square, and we get the form a square minus b square, and then we can apply the formula a minus b into a plus b. Here a is 1 and b is b minus c. So we get this 1 plus b minus c. So this becomes 1 minus b plus c multiplied by 1 plus b minus c. Okay. After 16 we have 23. I hope you can solve the remaining problems. They must be similar to the ones I am solving. 23 is 25 minus a square minus b square minus twice ab. Okay. So now this is definitely not in the form of, this is not a sum difference of two numbers, but if you can simplify, do a little bit of grouping, then it will help you. Like I can clearly see that this part is definitely of the form either a plus b whole square or a minus b whole square, because I can see the terms a square, b square and twice ab. So if I simplify this, or if I use some brackets, if I group this part, these terms, that is the second term, third term and fourth term as let's say plus, I have minus a square minus b square minus twice ab. I have this. Now from the expression inside the bracket, if I take minus common, because I can see all the terms are negative, so if I take the minus common, I will have a square plus b square plus twice ab, and we know that a square plus b square plus twice ab is from the algebraic identity, it is equal to a plus b whole square. Now 25 can be written as 5 square, and now we get the form a square minus b square, that is square of a difference of two squares. We get the form of difference of two squares. So now we can factorize it as 5 minus a plus b multiplied by 5 plus a plus b. So this becomes equal to 5 minus a minus b multiplied by 5 plus a plus b. Okay, let's do 24. 24 is 25 a square minus 4b square plus 28 bc minus 49 c square. Now this is a little bit complex or little bit hard problem, but it is very you must solve the problem from the basics. Now you see, this is a square term, this is a square term, this is a square term, and this term is having the variables b and c. So definitely you must try to see whether the square of b, that is the minus 4b square, and the square of c, that is the minus 49c square, and the term bc 28bc, this whole term, whether it is forming some square or not, because we are having b square, c square and bc. We know that a plus b whole square is equal to a square plus b square plus twice ab. So we have the terms a square, b square, and the term having ab. So we can see that in this except all the terms, second, third and fourth terms, they are having the terms b square, c square and bc. So probably they can be merged, they can be simplified or expressed as some square, either a minus b whole square or a plus b whole square. So let's see. So I have 25 a square. Now let's put them inside a bracket. So I have minus 4b square plus 28 bc minus 49 c square. Now we know that a plus b whole square, the identity from the identity, is equal to a square plus b square plus twice ab, and also we know the identity a minus b whole square is equal to a square plus b square plus minus twice ab. In both the identity of a plus b whole square and a minus b whole square, the a square plus b square is common. The square of a and b, they are positive. The only difference is in ab, in the term ab. In the a minus b whole square, it is minus twice ab, and the a plus b whole square, it is twice ab. So from this, if you want to create the form a plus b whole square or a minus b whole square, I want the square terms to be positive. So what I will do is, I see in this expression, that is the expression inside the bracket, the square terms are negative. That is, they are minus 4b square and minus 49c square. So let's see if I take out negative minus sign, negative as common from the expression inside the bracket. So I get minus 4b square minus 28bc, and I have plus 49c square. Okay, so I have 25a square. Now minus, so I can see now it is of the form a square plus b square minus twice ab, because 4b square is 2b square, 49c square is 7c square of 7c, and I have 28 bc is 28 bc is 2 into 2b into 7c. Now I can see that 25a square can be expressed as square of 5a, that is, and I see the expression inside the bracket is of the form a square plus b square minus twice ab. So it will be a minus b whole square, that is 2b minus 7c square. Now I can clearly see it is of the form, the entire expression has been transformed into the form a square minus b square. So the factorization will be 5a minus 2b minus 7c and 5a plus 2b minus 7c. So this is equal to 5a minus 2b plus 7c and 5a plus 2b minus 7c. Okay. Let's do 26. 26 is 100 minus x minus 5 square. So I can see it is of the form, so the difference of two terms, and the second term is already in the form square, that is x minus 5 square. And I also know the first term is 100, which can also be expressed as square, that is square of 10. So I have 10 square minus x minus 5 whole square. Now I have got the form a square minus b square. So the factorization will be 10 minus x minus 5 and 10 plus x minus 5. So this is equal to 10 minus x plus 5 and 10 plus x minus 5, which can be further simplified as 15 minus x and 5 plus x. Okay. Let's do 20 evaluate. Okay. So 27 and 28, we are asked to evaluate some given expression by using the concept of factorization. So 27, we have to evaluate 405 square. We have to evaluate this value, and 395 square. So this is a difference of two squares. So now we can easily factorize them as 405 minus 395 multiplied by 405 plus 395. Now 405 minus 395 is equal to 10, and this is 405 plus 395 is 800. So this is equal to 8000. 28 is the same thing, but the numbers are decimals, that is 7.8 square minus 2.2 square. So we can see it is of the form a square minus b square. So we will apply the identity of the factorization formula, a minus b into a plus b. So a minus b multiplied by a plus b, and we get 7.8 minus 2.2 is 5.6, and 7.8 plus 2.2 is 1. So this is equal to 5.6. No, sorry, I did some mistake. 7.8 plus 2.2 is 10. So this is 56. Okay. This was the selected problems from exercise 7b. Now let's do some problems from exercise 7c. The first one is we have to factorize x square plus 14x plus 49. Now, for solving or factorizing this kind of polynomials, you can see that this polynomial is a trinomial, is a quadratic trinomial, because it is a polynomial with 3 terms. So it is a trinomial, and also the degree of the polynomial is 2, because the maximum power of the variable is x square. So 2. Now, how will you proceed? How will you proceed to factorize? Will you, and also you can see that this is actually equal to, if you see, x square plus 14x and 49 is 7 square. So you can see the terms x square plus 7 square, that is a square plus b square. Now, will you now, so we know that how to factorize quadratic trinomial, that is of the form x square plus px plus q. So we have to find a and b such that a plus b is equal to p and ab is equal to q. If you then, this is one way. If you can find a and b such that a plus b is equal to q and a plus b is equal to p and ab is equal to q, then you can also apply this concept and proceed to factorize. But somehow, if you see that from the given polynomial you get the form a square plus b square plus twice ab, then you can directly apply the formula of a plus b whole square to create the factorization. In this example, for this example, I can see that I have x square plus 7 square, and I can clearly see 14x as 2 into x multiplied by 7. So I can now clearly say this is x plus 7 whole square. So this is the factorization. I did not apply the concept of the quadratic trinomial, that is finding the a and b. Now you could have also done that. You could have also applied the concept of finding a and b such that a plus b. So let's say what can be if I apply the concept of finding a and b such that a plus b is equal to 14 and ab equals to 49, that method will also work. So let's say 49. So 49 is equal to 7 into 7, and I can clearly see that 7 plus 7 is equal to 14. So over here, if I apply the concept of the form trinomial, quadratic trinomial finding a and b, then I can see that a will be 7, and b will be 7. And you know that if you find a and b, so this the factorization becomes x plus a multiplied by x plus b. So for this problem, if we apply after finding a and b, which is equal to 7, you can say that this will be equal to x plus 7 multiplied by x plus 7, which is equal to x plus 7 whole square. I would suggest that if you can see the form a square plus b square plus twice ab, then you can directly apply the formula of a plus b whole square. Okay, let's do 3. It is 1 plus 2x plus x square. I can clearly see this is equal to 1 square plus x square. We have a square plus b square, and I can clearly see 2x as 2 into 1 into x. So this is the form of a square plus b square plus twice ab. So I can say this is equal to a plus b whole square, that is 1 plus x whole square. Okay. Problem number 4. Problem number 4 is 9 plus 6z plus z square. Now this is equal to 3. 9 I know is 3 square, and I have z square. Now I will see whether 6z can be expressed in the form twice ab. So we must have 2 into 3 into z, which is exactly equal to 6z. So I know this is of the form a square plus b square plus twice ab. So this will be 3 plus z whole square. Okay, let's do problem number 7. It is 36a square plus 36a plus 9. I can clearly see that 9 is a numerical common factor from all the terms. So I would like to factor out 9 from all the terms. So we have 9 into 4a square plus 4a plus 1. Now I will try to see if I can factorize this expression. So 4a square is 2a, square of 2a, and I have 1 which can be written as 1 square. Now I need the term twice ab, where so I need 2 into 1 into 2a, which is exactly 4a. So now it becomes 9 into, we have inside the bracket a square plus b square plus twice ab. So this is equal to twice a plus 1 whole square. Okay. Then do problem number 9. We have z square plus z plus 1 by 4. Okay. So we have z square, 1 by 4 can be expressed as square, that is square of 1 by 2. So I got a square plus b square. Now I would like to see whether the remaining term in the polynomial z can be expressed as twice of z multiplied by 1 by 2, and I see exactly it is z. So I see the given polynomial is in the form a square plus b square plus twice ab. So this will be equal to z plus half square. Okay. Let's do problem number 10. Problem number 10 is 49 a square plus 84 ab plus 36 b square. Okay. So do I see any, can I factor out any numerical factor from all the terms? 36 is 4 into 9. 49 is 7 into 7. No, we cannot, we do not have any common numerical factor from all the terms. So, okay, so now 49a square is, we can express it as 7a square, square of 7a, and 36b square can be expressed as square of 6b. So I got the form a square plus b square. Now the remaining term, that is 84ab, we should be expressed as twice ab, where here a you can consider as 7a and b you can consider as 6b. So we must have twice into 7a into 6b, which is 14 into 6, 14 into 6 is 84ab, which is exactly what we have in the original polynomial. So we have now got the form a square plus b square plus twice ab. So now you can say this is equal to 7a plus 6b whole square, because a square plus b square plus twice ab is equal to a plus b whole square. Okay. Let's do problem number 12. It is 121 a square minus 88 ab plus 16 b square. Now these are relatively easy because you can see all the terms, that is the given polynomial, is exactly fitting the form of a square plus b square plus twice ab, or a square plus b square minus twice ab. So 121 is 11 square. So I can express 121a square as 11a square of 11a, and I have 16b square which can be expressed as square of 4b, and I have minus 88ab. Now let us see if we can express 88ab as in the form of 2 into ab, where in this case a you can consider as 11a and b as 4b. So we must have 2 into 11a multiplied by 4b, and we can clearly see this is equal to 88ab. So we have the form a square plus b square minus twice ab. So this will be 11a minus 4b square. Let's do problem number 13. It is 1 minus 6x plus 9x square. Okay. So I can see 1 can be written as 1 square, 9x square can be written as square of 3x, and I have remaining with minus 6x. Let us see if we can form the expression in the form of a square plus b square minus twice ab. So I must have 2 into 1 into 3x, which is exactly 6x. So I get the form a square plus b square minus twice ab. So this will be 1 minus 3x whole square. Now you can also write this as 3x minus 1 whole square. This, it will be the same, because 1 minus, because a minus b whole square is equal to b minus a whole square. Okay, let's do problem number 17. It is a square b square minus 6abc plus 9c square. Now, okay, so a square b square, we have three terms, and we can see that a square b square can be expressed as some square, that is, it will be square of ab, and 9c square can also be expressed as square of something, that is square of 3c. Now I see that the remaining term in the polynomial is minus 6abc, so I will try to see if I can have, if that can be expressed as minus twice ab. So I must have minus 2 into ab multiplied by 3c, and I see it is value is 2 into ab into 3c is 6abc, which is exactly the term in the given polynomial. So I got the form a square plus b square minus twice ab. So this will be a minus b whole square, that is ab minus 3c whole square. We can also write it as 3c minus ab whole square. Okay, let's do 18. It is m to the power 4 plus twice m square n square and n to the power 4. Okay, m to the power 4 I know can be expressed as a square of m square, that is, it is m square square of m square. Similarly, n to the power 4 is square of n square. So I got the form a square plus b square. Now I will see if the remaining term in the polynomial, that is 2m square n square, can be written as twice ab. So we can clearly see this is equal to 2m square and n square. So I have got the form a square plus b square plus twice ab. So this will be equal to m square plus n square whole square. Okay, let's do problem number 19. It is L plus M whole square minus 4ln. Now there is a problem, because in this is a difference of two terms. And the first term is square, is in the form of square, but the second term 4ln is not in the form of squares. Now you might be tempted, as for my previous discussion, that I said that a minus b can be factorized as a minus b can be expressed as a square of a difference of two squares, that is root a square of root a minus square of root b, and this is, there is nothing wrong in it. This is fine. This will be equal to product of root a plus root b and root a minus root b. This is fine. But in this particular example, if you now this is a very standard identity. You must always remember that a plus b whole square and a minus b whole square can be expressed using each other. That is, a plus b whole square can be expressed using a minus b whole square, and of course ab, and a minus b whole square can be expressed as a plus b whole square. So this is equal to a minus b whole square plus 4ab. You must always remember this formula, that a plus b whole square is equal to a minus b whole square plus 4ab, and the a minus b whole square is equal to a plus b whole square minus 4ab. So a plus b whole square is equal to a minus b whole square plus 4ab, and a minus b whole square is equal to a plus b whole square minus 4ab. These two formulas you must remember. Now, so now we can clearly say, if you remember this formula, you can clearly see that if L plus m whole square minus 4ln is nothing but L minus m whole square. Now you can also, so this was, I directly wrote this because I know the formula of L minus m whole square in terms of L plus m whole square. But if you expand from this given expression, if you expand the L plus m whole square, you will get L square plus m square plus twice Lm, and you have minus 4 Lm. So this is equal to L square plus m square minus 2 Lm. So clearly this is equal to L minus m whole square. Okay, so this was problems from exercise 7c. Now let's do some problems from exercise 7d. So the first one is problem number 3, which is z square plus 12z plus 27. Now z square is fine. Now if you try to express this polynomial in the form a square plus b square plus twice ab, you will see that z square is fine. Now you will need now 27 is not square. 27 is not a square. You cannot express 27 as a square of something. I mean 27 is not a perfect square. Is not a perfect square. So there will be a root. If we try to express 27 as the square of something, that something will have a root, but square root is not present in the 12z. So for this kind of problem, you should apply the concept of quadratic trinomial, the special form of quadratic trinomial, that is x square plus px plus q. You are given this polynomial, quadratic trinomial with the constants p and q. You will try to find a and b such that a plus b is equal to p and ab is equal to q. Then you can factorize this as x plus a multiplied by x plus b. So in this case, we must have a plus b is equal to 12 and a multiplied by b is equal to 27. Now how do you find a and b? The concept is that you factorize the value of a into b. So 27 is 9 into 3. Now 9 into 3, now you can see clearly 9 into 3 is 27, as well as 9 plus 3 is 12. Now this was simple, but for some numbers, you have to do a lot of factorization of the numbers. That is the product, the value of the ab, whatever the value is from the polynomial, you have to create all its factors and see. You have to find a and b such that a plus b will be equal to p. So for this problem, we immediately found that a can be, so a and b are 9 and 3. Now you can consider a as 9, b as 3, or a as 3 or b as 9. The two numbers a and b are you can consider 9 and 3. So I can so I know that a plus b, so p, we know that from the given polynomial x square plus px plus q, we know that p will be equal to a plus b. So I will express 12 as a plus b, that is 9 plus 3 z, and we have 27, 9 into 3 because Q is equal to AB. In this problem, Q is 27 and A and B are 9 and 3. So this. Now this is equal to Z square. You find this product. This is 9Z plus 3Z plus 20, 9 into 3. Now you form groups like this. This is group 1, this is group 2, and you can take a Z from common from the first group, and you have Z into Z plus 9, and you can have 3 common from the second group, and you have Z plus 9. So now you see both the groups are having common factor as Z plus 9. So the factorization will be Z plus 9 multiplied by Z plus 3. Now once you have found A and B, as I said, the factorization will be directly X plus A into X plus B. So I could have directly written, once I have found A and B is equal to, they are equal to 9 and 3, I could have written the given polynomial as Z plus 9 into Z plus 3. Okay, let's do 5. So it is x square plus 15x plus 56. So I have to search for A and B such that A plus B will be equal to 15 and A multiplied by B will be equal to 56. Now 56 is, I can if I factorize, do the factorization, 2 multiplied by 28. Now 2 and 28 will not help because 2 plus 28 is 30. I have to further factorize 28, that is, it is let's say 7 into 4. I have to form two numbers. I have to find A and B. Now from these factors 2, 7 and 8, 2, 7 and 4, how can we find A and B, two numbers, such that the product is 2 into 7 into 4 and their addition is sum is 15. So if I consider 14 and 4, the sum is 19. It will not work. Okay, so this can be further factorized as 7 into 4. 4 can be written as 2 into 2. Now I can see 7, if I see 1 as 7 and the other another A, 7 as A, and I can consider 2 into 2 into 2 is 8, 7 into 8. So I can clearly see that 7 plus 8 is 15 and 7 into 8 is 56. So I will write this as I can directly so the factorization of this polynomial you can say directly as x plus 7 into x plus 8 once you have found A and B. Once you have found A and B. But if you want to solve it step by step, it will be x square plus 7 plus 8x plus 7 into 8. Now you do this product and open the brackets, you get x square plus 7x plus 8x plus 7 into 8. You form groups, group 1, group 2, and from the group 1 you take x as common and I get x into x plus 7. From the second group you take 8 as common, you have x plus 7, and you can see the two groups are having x plus x plus 7 as the common factor. So this will be x plus 7 multiplied by x plus 8. This is the detailed step by step factorization of x square plus 15x plus 56. But in general, if you for the quadratic trinomial of this form, x square plus px plus q, if you can find A and B such that A plus B is equal to P and AB is equal to Q, this will imply you can directly factorize x square plus px plus q as x plus A multiplied by x plus B. Okay, let's do problem number 7. It is all about finding A and B. if you can, if there is possibility of finding A and B such that A plus B is equal to P and AB equals to Q, then the job is done. X square plus 13x plus 40. So definitely I cannot form this expression. I cannot express this polynomial as a square plus b square plus twice ab, because 13x cannot be expressed as twice ab. So I have to apply the concept of quadratic trinomial form. So I must have a plus b equals to 13 and ab equals to 40. Now what is 40? I have to factorize 40. So let's say 40 is 4 into 10. Now a and b cannot be 4 and 10 because 4 plus 10 is 14. It is now 13. So let's see what we can do. 10 is 2 into 5. Now so this is equal to 8 into 5. Now I see 8 plus 5 is 13 and 8 into 5 is obviously 40. So a and b can be 8 and 5. So this is equal to x square plus 8 plus 5x plus 40. This is equal to x square plus 8x plus 5x plus 40. Now I am not using directly. Directly I can say that this is equal to x plus 8 multiplied by x plus 5. But I am doing step by step. So I will form the two groups. This is group 1. This is group 2. And we'll take x from as common factor from the first group, and I have x into x plus 8, and from the second group I will take 5 as common factor, and I will have 5 into x plus 8. So now I see both the groups are having common factor as x plus 8, so this will be x plus 8 multiplied by x plus 5. Now okay, so these are all similar kind of problems. The only thing is that you have to find a and b. 8 is x square minus 17x plus 16. So a plus b must be 17 and ab must be 16. Now what is 16? 8 into 2. Now 8 plus 2 is 10. It is not working out. Okay. Okay, so this was a little bit tricky. So 8, 16. Now 16 can be written as 16 into 1, and I can see that 16 plus 1 is 17. So this will be equal to x square. So the numbers a and b are equal to 16 and 1. So I can write it as 16 plus 1 x plus 16 into 1 or 16, doesn't matter. So x square minus now 16x minus x plus 16. You form the group x square minus 16x and minus x plus 16 from the first group. From the first group, you take x as common. You get x into x minus 16, and from the second group there will be no common, but you can say it is equal to minus of x minus 16. Now I can see x minus 16 as common factor in both the groups. So this will be x minus 16 multiplied by x minus 1, because x minus 16 is nothing but x minus 16 multiplied by 1. There is always a 1. Let's do this was problem number 12. Sorry, this was problem number 12, not 8. Okay, next is problem number 14. Next is problem number 14. 14 is x square minus 22x plus 117. Okay, so a plus b must be equal to 22 and a multiplied by b must be equal to 117. So we have to start from ab, the value of ab. So 117 can be factorized as 9 multiplied by 3. No, not 3, but 13. 9 into 13 is 117. Now, also you can see that 9 plus 13 is equal to 22. So, obviously, A and B will be equal to 9, 13 or 13, 9. It does not matter. So, this is equal to x square minus 22 can be written as 13 plus 9. We have x, and 117 is 13 multiplied by 9. So, this is x square minus 13x minus 9x plus 13 into 9. So, you form the groups. This is group 1 and this is group 2. You take out x common from the first group, and you have x multiplied by x minus 13, and you take 9 common from the second group. Let's say you take 9 common from the second group, and you have minus x plus 13. So, this is equal to, you can say, okay, so this is x into x minus 13, and from the second group you can take minus x minus 13 you can take minus 1 common, and you have minus 9 into x minus 13. Now you see x minus 13 as common factor in from both the groups, and so the final factorization will be x minus 13 multiplied by x minus 9. Oh, I'm sorry, I did a mistake. A plus B will be minus 22, not 22. A plus B will be minus 22, and AB will be, and AB is 117. So, A and B will not be 9 and 13, but A and B will be minus 9 and minus 13, since their addition has to be minus 22. So, that is the reason, that is the reason if you apply directly the factorization method, once you have found A and B, A is, so it will be A is, so it is Ax plus A multiplied by x plus B, and A is, you know that A and B are minus 9 and minus 13. So, this will be x minus 9 and x minus 13. Okay, let's do problem number 21. It is a square plus 6a minus 91. So, I must have a plus b equals to 6 and ab equals to minus 91. Now, minus 91 is equal to, it will divide with 7. So, you can have minus of 7 multiplied by 13. Minus of 7 and multiplied by 13. Now, if you add minus 7 and 13, it is equal to 6. So, you can have A and B as minus 7 and 13. So, directly, if you want to factorize directly, the factorization will be A minus 7 multiplied by A plus 13. But let's do it step by step. This is A square, and we have found A and B. Please do not confuse with the A and B on the right hand side with the A in the polynomial. So, 6 can be written as 13 minus 7 A, and minus 91 is 7 into 13. So, this is equal to A square plus 13A minus 7A minus 7 into 13. So, let's form the groups. Group 1, group 2. So, take A common from the first group. We have A into A plus 13, and you can take 7 from the common from the second group, and you have minus 7 and A plus 13. So, A plus 13 is common from both the group, and hence the factorization will be A plus 13 multiplied by A minus 7. Now, I will skip a few selected problems. I think the concept is same. You have to just figure it out. The A and B from the value such that A plus B is equal to the P and AB equals to Q, you will start from AB and you will try to factorize the Q in the given polynomial, the Q, factorize it, and you will try to see combination of two numbers from all the factors of AB such that their sum is P and their product is Q. So let's do the last problem. I will skip 20, 31, 32, 30, 31, 32, 34, 37. I think they are all same. The concept is same. I will wind up this video by just solving the last problem, that is 7x square minus 19x minus 6. So this is of the second form of the trinomial, quadratic trinomial, that is px square plus qx plus r. So you have to find a and b such that a plus b is equal to q and ab is equal to p into r. So for this problem we have to find a and b such that a plus b will be equal to minus 19 and ab will be equal to minus 6 into 7. Now minus 6 into 7, as you can see, minus 6 plus 7 is not minus 19. But minus 6 can be written as minus 2 into 3 into 7. And 7. Okay. Now, so the addition has to be minus 19. So how can you choose A and B such that their sum is minus 19, and so if you do like this, minus 2, 3 into 7 is 21. 3 into 7 is 21. Now minus 2 into 21, minus 2 plus 21 is plus 19. So what you can do is, you can always write it as 2 into minus 21. Now you will see that minus 21 plus 2 is minus 19, and obviously their product is minus 6 into 7, that is 42, minus 42. So I can say that A and B are 2 and minus 21. So directly, if you use the direct formula, the factorization will be x plus 2 and x minus 21. If you want to do step by step, it will be 7x square minus 19. You will write as plus 21 minus 21 plus 2 x, and you have minus 6. So this is equal to 7x square minus 21x plus 2x minus 6. So this, you can form a group. This is the first group, this is the second group, first group, second group. From the first group, you can see, you can take 7x as common, and this will be x minus 3. And from the second group, you can take 2 as common, it will be 2 into x minus 3. Now you can see that both the groups are having common factor as x minus 3. So the final factorization will be x minus 3 multiplied by 7x plus 2. 7x plus 2. Oh, sorry. I'm sorry. For the quadratic trinomial of the form px square plus qx plus r, once you have found a and b, the final factorization is not actually this is wrong. This is wrong. The final factorization is not actually ax plus a multiplied by x plus b. That will only work for the quadratic trinomial of the form x square plus px plus q. For this form px square plus qx plus r, once you have found a and b such that a plus b is equal to q and ab equals to pr, the factorization will not be x plus a into x plus b. No, you have to manually put the way I did step by step. So the final factorization is x minus 3 into 7x plus 2. So this brings to an end in solving the problems of 7b, exercise 7b, c and d based on the concept of factorization of some special form of polynomials. I hope this video was beneficial. If it is so, then please like it and share it with your friends. And also, once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. in the next video, I will solve the objective questions, that is 7E, which will have a lot of MCQ problems based on all the entire concept of the chapter factorization. So please stay tuned for the next video, and that is all for this video. Thanks for watching, and until the next video, take care and bye.